Where possible, factor the following trinomials by inspection. When they say where possible, what they're warning you is that some of them will not be. So whenever you see that magic word, if you've been working on one of these problems for more than like 6 hours and you're not getting anywhere, consider the possibility that maybe it can't be factored. So here, for example, what we need is, first, if it's going to start with a squared, about the only way you can make a squared is a times a, so factoring that part is easy. But now, here's the tricky part. We need two numbers in these second spaces, which, when we multiply them, will give 30. Well, there's several ways you can do that. That could be 1 times 30. It could be 2 times 15. It could be 3 times 10. 4 doesn't go into 30. It could be 5 times 6. Any one of these pairs would work for multiplying to 30, but also those two numbers have to add up to 11. Because when you FOIL this, the outside and inside pieces are where we're going to get that 11a. You can put pluses or minuses on those numbers as you require. So looking at these, 1 and 30, it doesn't matter what I do with the signs, I'm never going to get 11 out of these two numbers. I can add them and get 31, I can subtract them and get a 29, that's it. So no good. 2 and 15, depending on the signs, I could either make those add up to 17 or I could make them subtract out to 13, so that's not it either. 3 and 10, you can either make a 13 or a 7, but that's it. But 5 and 6, if we put plus 5 and plus 6, then here's what happens when you FOIL this. We're going to get first times first, a times a makes a squared. Good, we were supposed to get that. Outside will give us a 6a. Inside will give us a 5a. And then last will give us 5 times 6 is 30. So this works. We get our a squared, which we were supposed to have. We get our 30 on the end, which we were supposed to have. And 6a and 5a combined to make the 11a, which we were supposed to have. So that's the correct combination. We say that this factors to a plus 5, a plus 6. We'll see what happens when they give us some more complicated numbers here. I'm just going to shrink that down because we're going to need the space. Okay, b squared minus b minus 30. Here, that middle coefficient is minus 1b. And away we go. B squared had to come from b times b. That part's simple. Again, it's 30, but so we have the same possibilities as before. We could have 1 times 30, 2 times 15, 3 times 10, or 6 times 5. But now, those two numbers have to add up to minus 1. 1 and 30 can't combine to make 1 no matter what you do. Neither can the 2 and the 15 or the 3 and the 10. But if you have minus 6 and plus 5, that works. How did I get that? Looking at the numbers, here's our combinations. 5 times 6. You need two of these numbers that are only different by 1, so that when you subtract them, you can get a result of minus 1. So these, if you add them, you get 31. If you subtract them, you get 29. Useless. These two, if you add them, you get a 17, or if you subtract them, you get a 13. No good. These, if they have the same sign, you get 13. If they have different signs, you'll get a 7. And here, if these have the same sign, you get 11, and if they have different signs, you can get a 1. So this is the combination that can give us minus 1b. Let's see what they give us next. X squared minus 4x plus 48. Okay. X squared will come from x times x. Now the tricky part, 48. There's lots of ways to make 48. It can be 1 times 48. It can be 2 times 24. It can be 3 times 16. It can be 4 times 12. 5 doesn't go in. It can be 6 times 8. 7, and 8 is already on our list, so once you get to 8, you know you can stop. So, where's a pair of numbers here that can give us 4, that can add up to 4? No, 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 no. This can give us either 8 or 16, depending if they're same or different signs. And 6 and 8 can either add up to 14 or subtract to give 2. So there's no combination that can make -4, which means this one cannot be factored. It's almost never obvious when something can't be factored. What happens is you run the usual drill on it, you try to find numbers that will multiply out to produce that, and you simply can't do it. And if you've got a complete list, like I did there, of all the numbers that can multiply to 48, and you've checked them all, then it's time to throw up your hands and move on. In this case, we couldn't find a combination that could add up to -4x. Last one. And, oh look, they did it again. You might remember from an earlier example where they gave us something to factor, which had a common factor hiding in it. They did it again. That should always be the first thing that you address when you're factoring an expression is, does it have any common factors? Here, I can take out two things. Do you see what they are? 3, 21, 36. We can take out a 3, and also, each of these terms contains x to at least the first power. I can factor out a single x, and I'm left with 3 divided by 3 is 1, x cubed divided by x is x squared. Negative 21 divided by 3 is negative 7, x squared divided by x is x. 36 divided by 3 is 12, x divided by x is gone, it cancels out. So, there's the common factor out. Now, next step. Keep the 3x. Can we break down x squared minus 7x plus 12? Are there, we'll need x times x, of course, here. Are there numbers which add up to -7 and multiply to 12? Here's the ways I can think of to make 12. So, can these add up to -7? No. In short, you can get 13 or 11 with these, depending how the signs are. 2 and 6, 8 if they have the same sign, or 4 if they have different signs, so that's no good either. 3 and 4, hey, if we have -3 and -4, that would do it. When you FOIL this, you'd get x times x is x squared. You'd get -4x and then -3x, which combine to make our -7x. And the -3 times -4 would give us our +12. So that's factored.